All right, we are continuing our discussion in 8.1. This video is over multiplying and dividing rational expressions. Go ahead and pause the video so that you can fill in the blanks that I already have listed here. When multiplying, you do not need common denominators. Remember, rational expressions are just expressions that are really fractions. And whenever we multiply fractions, we don't need common denominators. The first thing that you should do, just like simplifying that we did in the previous video, is we are going to factor everything first. Once everything has been factored, we can multiply the top times the top and the bottom times the bottom, just like multiplying fractions. Multiply the numerators, then multiply the denominators. And then finally, you're going to work to simplify. So let's work through E and F here. Now in E, those are all one term on top and bottom of each of those rational expressions. So I don't need to factor anything for those. I'm just going to practice multiplying the numerators and then multiplying the denominators. So I have the top times the top. And then the bottom times the bottom. So on the top, I have 27 times 8, which is 216. And all of those variables can be combined. None of them are the same, so their exponents are going to remain the same. Then on the bottom, I have 16 times 9. That's 144. And I have 1x. This time I now have 4 y's and 3 z's. And now we reduce or simplify. Now, the 216 and the 144, those are just a fraction that you reduce. What's the largest number that can go into both of them? And you can reduce by hand that way. Alternatively, remember your calculator can help you reduce as well. 216 over 144, and then you're going to change that to a fraction. So it reduces down to just 3 halves. I have an x squared on top and an x on the bottom. Remember, our exponent rules mean that we're going to divide exponents, so divide the bases, so we're going to subtract the exponents. So I have an x remaining on top. The y's are completely gone. Again, this goes back to our simplifying that we did yesterday. Each of these are just factors. And so if it's helpful for you to put them in parentheses as separate factors so that we know that we can cancel, that's absolutely fine. I have a y to the 4th on top, a y to the 4th on the bottom. They're gone. The z on top, z cubed on the bottom, leaves me 2 z's on the bottom. So my final answer is just 3x over z, 2z squared. Now, the next one, these all have different terms in them, so it requires us to be on our factoring game here. So we are going to factor the top and factor the bottom of each of these rational expressions. That means that you're going to have to use your box. You might need a little bit more room. But if you're watching this video, I want you to pause it, and I want you to practice this factoring on your own, and then you can check your answer with what I have. This is what it should look like completely factored. And remember, when we are multiplying, we're multiplying the top times the top, the bottom times the bottom. So what's going to happen is it's going to make it one giant fraction. Step 3 is just to simplify. So we are looking for identical factors on the top and identical factors on the bottom. So I have an x minus 7 on the top, and there's an x minus 7 on the bottom. I have an x minus 4 on top and an x minus 4 on the bottom. So both of those are going to get to cancel, leaving me with just x plus 3 on top, and on the bottom, x minus 2, x plus 5. It's really not necessary to FOIL that back out. Leave it the way it is. If you did, it wouldn't necessarily be wrong. You're just opening yourself up to potentially more issues. Now that we've taken a look at multiplying, let's take a look at dividing. Dividing has many of the same rules. It does not require any common denominators. One of the common things we see is people trying to take the denominators and make them common, especially after we learn to add and subtract. So please be very careful and don't fall into that trap. The second step is to flip the second expression. Remember, to divide fractions, we multiply by the reciprocal. So please, please, please make sure that your second fraction is always flipped into the reciprocal. And then we're going to follow those same rules for multiplication, where we do top times the top, bottom times the bottom. Just like in multiplication, our first and our last step are factor everything and then simplify. So in looking at G, those do not have any addition or subtraction signs, so there's no factoring that's going to happen here. We're just going to skip down to the second and practice the actual division process. So we are going to rewrite the first fraction the way it is. And we are going to flip the second fraction. So 26b on top, 36xy cubed on the bottom, and we're multiplying. Remember, when you multiply, it becomes top times top, bottom times bottom, one giant fraction. So on the top, I have 12 times 26, which is 312. X cubed, y, and a b. On the bottom, I have 13 times 36, which is 468. And I have an x, a y cubed, an a, and a b squared. Again, we can use our calculator to help us simplify this. So I have 312 divided by 468 and change it to a fraction. And I have 2/3. Taking a look at the variables, I have x cubed on top and x on the bottom, leaving me with x squared. Y on top, y cubed on the bottom, leaves me with a y squared on the bottom. The a does not have anything on top, so it just remains at the bottom. B squared on the bottom, b on top, leaves me with a b on the bottom. Now we're going to get some more practice with our factoring. We have x squared minus 4x minus 21 on top. And then the bottom, we have x squared minus 6x plus 8. So take a moment, pause the video, and try and factor this on your own. You're going to need your boxes and all of that. But our first step is to factor the top and bottom of each of these. Now you may notice that this was the same factors as what we did in F above. So it should have been pretty easy for you to check to make sure that you're doing it right. And if you didn't do it right on the previous one, hopefully it gave you another opportunity to get those factors right. So when we divide, remember we keep the first one exactly the same. X minus 7, x plus 3. The bottom, x minus 2, x minus 4. And we are going to change it to multiplication after we flip the second fraction. So flip the second fraction, and now we have multiplication, one giant fraction. And we are checking to see, are any of these factors identical so that we can cancel? I have x minus 7 on top and bottom, x minus 4 on top and bottom, and I'm left with just x plus 3 over x minus 2, x plus 5. All right, for H, again, our first step is to factor everything, top and bottom of both fractions. The top, I hope you can recognize, of the first fraction is going to factor down using that pattern we've used a few times already. A minus b and a plus b, or a plus b, a minus b, whichever way it goes about it. The bottom, before you start into your box, please recognize that I could take a 3 out of all of that. Same thing will apply over here for the top. I could take a 4 out. And the bottom over here will factor to a plus 1, a minus 1. That means the only thing left that you need to factor is this a squared minus 2a plus 1. Which, if you want to pause the video, give yourself a chance to factor those. And we'll factor down into a minus 1, a minus 1. When dividing, we keep the first fraction identical. And then the second fraction is going to flip. A plus 1, a minus 1 is going to go on the top. And 4, a plus b is going to go on the bottom. And we are multiplying. Remember, multiplication, we multiply top times top, bottom times bottom. So we're looking for identical factors. I have a plus b on top, a plus b on bottom. A minus 1 on top, a minus 1 on the bottom. I don't have a 3 on the top, I don't have a 4 on the top, I don't have a minus 1 on the top, so nothing else can cancel. The top becomes a minus b, a plus 1. The bottom becomes 3 times 4, which is 12. And then I'm still left with an a minus 1. Now, J is what we call a complex fraction. And it's defined up at the top there as a fraction that contains another fraction. Rewriting this so that the numerator and the denominator are single fractions will help change it into a division problem, which will make it a little easier for you to work through. So for J, the first thing that I'm going to do is I'm going to rewrite this as a division problem. A cubed b cubed over x y to the fourth, a squared b over x squared y. And this big dark fraction bar is going to stand for our division. There's no addition or subtraction signs, so I don't have to work through finding out factoring or anything like that. I just need to flip the second fraction. So the first fraction remains the same. I'm multiplying. Oops. I forgot to flip as I was writing. So I have a squared b on the bottom and x squared y on top. And when we multiply, it makes it one singular fraction, top times top, bottom times bottom. So I'm looking for a cubed on top, that's a factor, a squared on the bottom, that's a factor. I can reduce those to just an a on the top. B cubed on the top, b on the bottom becomes b squared on the top. X squared on the top, x on the bottom leaves me with just an x on the top. Y on top, y to the fourth on the bottom leaves me with y cubed on the bottom. Got one more complex fraction for us to work through. This one has addition and subtraction signs, so there's going to be some factoring that is going to have to happen. But your first step is to rewrite it as a division problem. For x over x plus 6 and x squared minus 3x over x squared plus 3x minus 18. And remember that big dark bar changes to our division. So we're going to first factor everything. The first fraction, there's nothing to factor. There's no exponents for me to deal with or anything of the nature. The second one, I look at the top and I can see an x coming out of the first and second term, leaving me with x minus 3. And the bottom, I need to use my box, the whole a times c, and walk through that. You may want to pause this video so that it gives you time to walk through that method. Oops. So I have an x plus 3, or an x plus 6 and x minus 3 to round out the bottom here. We need to flip our second fraction. And we're going to make it multiplication now. So now that it's multiplication, we have one giant fraction. And I'm just putting parentheses around all of my factors, because anything inside those parentheses can then cancel. So I have an x on the top and an x on the bottom. Those will allow me to cancel the x's. X plus 6 and x minus 6, or x plus 6 and x plus 6 will cancel. And then x minus 3 will cancel, leaving me with my answer to be just 4.